Today we're going to start our second conic section, the ellipse. Hopefully you have your notes in front of you. We're going to look at it in the same way we did the circle. When we first began our discussion of the circle, the first thing we did was we defined the circle. And we define the circle as the set of all points in a plane equidistant from a fixed point called the center. After defining the circle, we talked about how it was formed. And we talked about the circle as being formed by the intersection of a plane and a cone, where the plane was perpendicular to the axis. The plane is perpendicular to the axis, and that formed the circle. Next, we looked at the equation of a circle with center at the origin, and there was our equation. Following that, we moved the center. We moved the center HK, and we came up with our new formula. And we also talked about the fact that certain things have more than one equations. For example, a line has the standard form, it has the slope-intercept form, and the point-slope form. With circles, we also have a general form. So the last thing that we did with our circles is we looked at this general form, and then we transformed it into the standard form, the HK form, by completing the square. All right, so that's exactly what we're going to do with our ellipse. The first thing that we want to do is talk about how the ellipse is formed. So I've enlarged this a little bit. Okay. So we have our axis, and this is called our generator. And we spin the generator around the axis, forming our double-naped cone. With the circle, we took a plane and we intersected it at a 90-degree angle with our axis. Our axis is in here somewhere. Now, with our ellipse, we are going to intersect our plane at an angle that is less than 90 degrees, but greater than the angle formed by the generator and the axis. So let's take, for example, if this angle were, let's just say, 40 degrees. If I intersected a plane at an angle greater than 40 degrees, so if this angle is 40 degrees, and I intersected this cone with a plane, and this angle, let's say, were 50 degrees, the intersection of the cone and the plane would then form an ellipse. And hopefully we've looked at some of the animations and some of the videos. If not, I will be assigning them. All right, so let's write that down. An ellipse is formed whenever the plane intersects the cone at an angle less than 90 degrees and greater than the vertex angle. And that's the angle formed by the generator and the axis. Okay, good. All right, so we're going to flip back and forth between the pages here. Let's just start here, naming the parts of the ellipse. The first thing we want to do, though, is to define the ellipse. We've seen how the ellipse arises from the plane intersecting the cone, and now let's take a look at the definition. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, called the foci, F-O-C-I, is a constant. All right, so let's go back and see what that is saying. In this picture here, it's saying I have two fixed points. Focus 1, focus 2, two of them together, foci. Let's say this distance from the focal point to a point on the ellipse, let's say that was, 3 units. And let's say this distance were 10 units. The sum of these two would be 13 units long. Now, if I chose a different point, this is longer. Let's say that's 5 units long. This, since the total distance traveled from the ellipse to these 2 points is 13, and if this is 5, this would have to be 8 units long. So as one gets longer, the other one gets shorter, and the sum of those two is always equal to a constant. So what it's saying is from P1 to F1 plus P1 to F2 equals the sum of these distances, which equals the sum of these distances. And that's the definition of ellipse. We take two fixed points in space, and then we travel around at a fixed distance. Okay. I'm going to see if I can prop that up. It looks kind of small. Okay, that's better. The ellipse has two axes of symmetry. The longer is called the major axis. Okay, so we have an ellipse here. It's an elongated circle, if you will, with one axis being longer. The longer axis, the major axis, contains the foci. In the diagram below, take a second and name that longer axis. All right, the longer axis is a segment, and we can call it DA or AD, doesn't matter. AD with a segment over the top. So segment AD is the major axis. And the endpoints of the major axis are called the vertices. A is a vertex, D is a vertex. Together they are the vertices. All right. The shorter segment. Well, if this is the major axis, the shorter one is called the minor axis. In the diagram below, take a second and name that minor axis. It is segment BE, with a segment over it. And that is the minor axis. Well, if these endpoints are called vertices, the endpoints of the minor axis are called co-vertices. Okay, so let's just zip around here and name the various things. This is pointing to B. Point B is a co-vertex. Point A, vertex. It is the endpoint of the major axis. This line here is pointing to this distance from B to E. So this is the minor axis. This is pointing to point E. co-vertex. Point D, vertex. This distance here is the major axis. And finally, I know this is the origin on the coordinate plane, but in terms of the ellipse, this is called your center. And an ellipse is completely symmetrical. It has two lines of symmetry, a horizontal line and a vertical line. Sometimes the horizontal line is the major axis, but the ellipse could also exist like this, where the horizontal line is the minor axis. So don't think that our ellipses are always going to be stretched horizontally. They can be elongated vertically as well. Okay, so the major axis is a certain length, and we're going to come down here, and it's just customary to use these letters to describe the distance between 2 points. So we use a little a to describe the distance from, this would be our center, to our vertex. Okay, so this distance from center to vertex is called the semi-major axis. And again, it could have been drawn vertically as well, and A would have been this vertical distance from the center to the vertex. B is the distance from the center to the co-vertex, and it is called the semi-minor axis. And C is the distance between the center and the focus. So this distance here is going to be equal to this distance here because it's symmetrical. Semi-minor and semi-minor are going to be equal. Semi-major and semi-major are going to be equal because the ellipse is symmetrical around the horizontal and vertical lines. Okay, let me end it there.